Hi everyone. Welcome to the fourth episode in our exciting new webinar series, What's Coming from 12D. My name is Lisa Stewart and I'm the Marketing and Communications Coordinator at 12D Solutions. These webinars showcase features that will be included in upcoming versions of 12D Model and 12D Synergy to give you an idea of what to expect when the versions are released. We'll keep running these webinars regularly in coming weeks and recording them for posting on our YouTube channel with links through our website. During this presentation, you'll be able to type your questions along the way, as shown on the screen. We'll answer as many as possible of those throughout the webinar, and at the end, I'll read out some of your questions to the presenters. Today's webinar, Sub-Grid Sampling and Quadtree, will be presented first by Chris Huxley. Chris is a principal engineer for TUFLOW with over 17 years of experience in the field of flood, stormwater modelling and floodplain management. Chris is currently a senior member of the TUFLOW hydraulic modelling software development team. He is also an adjunct lecturer at Central Queensland University, where he teaches hydraulic modelling. Prior to his current role in the software development and teaching sectors, Chris worked in consulting and successfully carried out and managed numerous catchment-wide riverine and stormwater flood studies and floodplain risk management investigations throughout Queensland and New South Wales, as well as over in California, USA. We'll also hear from Robert Graham, our resident water resources engineer, with over 20 years of experience here at 12D and over 30 years in the hydraulic and hydrological modelling field industry. Commencing with physical hydraulic modelling and river surveys, Rob's projects moved focus onto numerical modelling for flood and hydroelectric studies. In 1985, he began developing hydraulic models with close linkages to data terrain modelling software. Today, he leads the integration of TUFLOW inside 12D Model. TUFLOW's recent implementation of Sub-Grid Sampling and Quadtree grid refinement produces quality results without the need for a small cell size throughout the entire TUFLOW grid. 12D Model has both of these features in our version 15 release. Chris and Rob will discuss the detail behind these improvements and how they have been implemented into 12D Model 15. Over to you, Chris.
Thank you for the opportunity to present today. Look, this presentation is going to provide you with an overview of two new features in TUFLOW and also discuss the implications they have on your modelling. The two features are Sub-Grid Topography Sampling and Quadtree Mesh Refinement. Let's start with Sub-Grid Sampling. This one here comes free with HPC. You don't have to purchase a new module to access this feature. The image that we're looking at here is your traditional cell volume phase schema, where we have a single elevation point at the center of each cell defining a flatbed volume for each cell, and also an elevation point along the mid-side of each cell face defining when water can move from one cell into its neighbor. That approach is replaced with a series of curves in the subgrid sampling schema. We have a volume elevation curve to define the volume in each cell, and also a face width elevation curve along each face. Now, implementation of this new approach actually has some pretty significant benefits. It eliminates loss effects associated with a mesh which is not aligned with steep side channels in an urban setting. It also means that you can actually achieve equivalent accurate results at a larger cell size. And using a larger cell size means that you require less cells in total and faster simulation speeds, which equals faster simulation speeds. Also in the urban setting, this new approach picks up the depth information at your inlet, your pit inlets a whole lot more accurately, and therefore means your pipe network modelling will be more accurate too. Let's talk about the loss effects first. And it's easiest done by looking at a very simple benchmark test case. Here we have a rectangular channel with a known length, known width, known flow, slope, and Manning's N. And from that information, we can calculate a known answer, both in terms of water level and energy slope. If we create a TUFLOW model of the same test case, we can then compare its results against the target answer just using the Manning's equation. This result here is using TUFLOW Classic and the traditional cell schema. When the mesh is aligned with the channel, the model result matches the target answer really nicely. As we start to orientate our mesh though, you'll see that the model result actually doesn't match the target result as nicely. So the model result's there in blue, the target answer is in red in those graphs along the bottom. And it turns out that in situations like this where you don't have many cells across the channel and there's a wet-dry interface along the banks of each channel, there's an artificial loss that occurs along that wet-dry interface, and that drives your water levels higher than what you'd hope to achieve. If we run the same test model using SGS across that same series of different orientations, you achieve this result. The graphs on the bottom show that you actually get really great agreement with the target answer for all those model scenarios. So it's a great improvement in accuracy. It's one thing to do a really small benchmark test. It's another to apply that modeling approach to a broader catchment area and just see how it impacts the results. I'm going to give this information here was published at the link in the bottom of the page here, so I highly recommend you go there. I'll really focus on the results of it, so there's a lot of information for you to absorb. But basically, Duncan, who's our UK manager, did some testing using different cell sizes and both the traditional approach and the sub-grid sampling approach. Did lots of testing to see how much that influenced flood damage estimates for this subcatchment within London. And I'll skip straight to the results. This first series of 5 graphs are using TUFLOW Classic and the traditional cell schema, so not SGS. The title of each graph highlights what model version it relates to. So on the left we have a 1 meter resolution model, second from the left is a 2 meter, third from the left is 5 meter, then we have 10 and 20 off to the right. The x-axis is the flood depth result for that modeled resolution, and that then is plotted against the y-axis, which is the depth result for that exact same location, though for the 1 meter model, the 1 meter resolution model. By plotting one versus the other, you can see where that coarse resolution model is in agreement with the finest resolution model or in disagreement with it. And these graphs here obviously show that as you move to a coarser resolution, the agreement with that finest resolution estimate becomes worse. Let's now look at the exact same model testing, though with SGS. And it's immediately apparent that you get far better agreement between your model scenarios across all the ranges of resolution than what we did without SGS turned on. So here it's a really great demonstration of the fact that using SGS you get that higher accuracy result at a coarser resolution. In addition to what's happening above ground, if you are doing pipe network modeling, you'll actually find you'll get greater accuracy results throughout your entire pipe network as well. And it's simply due to the fact that the sub-grid sampled approach defines the depth of flow at all of your pit inlets more accurately than the old traditional approach. So look, in summary, sub-grid sampling is an excellent feature due to all the reasons we've discussed. It eliminates that numerical loss effect along the wet-dry boundary. By default, it just represents your above-ground topography more accurately. That in turn means that you can build models using a coarser cell size, which will mean less cells and faster simulation. And then if you're doing urban modeling, which has an underground pipe network model feature, or has underground pipe network inputs, You'll also define the flows through that pipe network more accurately because the inlets or the flow depth details at your pit inlets is better represented. Let's now look at Quadtree. Quadtree allows you to split one grid cell into 4. It basically means that you can refine your model resolution when and where you want to achieve improved accuracy. There's 2 ways that you can implement Quadtree. You can manually specify each level of nesting, where you define an area where you'd like to nest it down, then just apply the nest level for that particular region. And we've built in the functionality to accommodate for 9 different levels of nesting. Alternatively, you can use an inbuilt automated level approach. Is that the right word? Level approach? I guess so. Where rather than manually stepping down one level at a time, you can define a target level, which is your finest resolution, and TUFLOW will automatically transition from that finest resolution out to your coarsest resolution. The development team have done an amazing job with the implementation of Quadtree in that it will automatically assign all of your boundary conditions, all of your 1D, 2D connections appropriately in each of the various domains or nest levels without you needing to have to do anything at all. So you can really just focus on where do I want fine resolution and how fine do I want it to be. It has pretty big implications when you're dealing with big urban settings. This one here is Phoenix, Arizona. We built this model across the entire area, took the roads network layer, applied a level 4 value to the roads layer, and TUFLOW automatically created this mesh for us, stepping from level 4 out to the coarsest resolution. And it also automatically assigned all the different boundary conditions from that original single resolution model and also the 1D, 2D linkages for us. One of the benefits of this approach over the prior 2D, 2D linking approaches we had is that it's incredibly stable. This here is an example of a dam breach scenario where there's a building downstream of the dam breach location, and we've intentionally applied the Quadtree nest location through an area which transitions from subcritical to supercritical and back to subcritical flow, and it's obvious that there's zero stability issues whatsoever. It's a really robust solution that the development team implemented here. Let's look at how much Quadtree will be able to speed up your simulations. It's good to just do a little test case here. We're looking at Innisfail, where we're comparing a single resolution model, which is on the left, to a Quadtree model, where the finest resolution matches the equivalent single domain model resolution. And you can see by stepping out 3 levels for all these different versions of the same model, we're able to reduce the number of cells by about 80%. So it's a pretty big reduction in cell count. So the largest model there, let's see, from 12 million cells down to 2.5 million. That's a big reduction. Let's see, what does that translate to in terms of model speed up? Across the board here for these 4 different benchmark cases, the speed up ratio went from, let's see, 1.3 up to 4.1. So it's a pretty significant speed up. It's one thing for the product developers, so us, to present these benchmark results to you. It's another when someone from industry just independently creates their own benchmark data set and achieves similar results and likes it so much they actually write an article on it. And that's what we have here. The link is across the bottom if you'd like to look at this article in detail. In short though, Bureau Happold purchased Quadtree and did their own testing. It was a similar test case where they implemented 3 levels of nesting using the roads layer. That's what's shown there. And using that approach, they were able to reduce the number of cells by 85%. That subsequently reduced their simulation times by 70%. And when they compared the water surface elevation between a single domain model that had a target resolution, that had a single cell resolution versus that Quadtree version, in 97% of cases across the entire model area, the results agreed within plus or minus 100 mils. So it's a great result. Well worth a read. So yeah, look, in summary for Quadtree, it's worthwhile noting that in a like-for-like sense, Quadtree actually does run slower. So if I was to run Quadtree just using a single resolution, because it's a mesh solution, it would run slower than HPC, which is a grid solution. But once you implement some intelligent mesh design, so very selective about where you're refining your mesh, you can get some great runtime benefits. Your models can run a whole lot faster. Other benefits with this solution are the implementation simplicity. It literally takes minutes to implement. And also the numerical stability. It's a really robust solution. That actually covers everything I was hoping to present today. So I hope that you've enjoyed the presentation. I'll pass over to Rob now, who will give a demonstration how to implement this using 12D.
Thank you, Chris, for that background on SGS and Quadtree inside TUFLOW. What we're going to do now is move across to 12D model and look at a live presentation on how SGS and Quadtree are implemented inside 12D. For those of you that haven't seen TUFLOW inside 12D before, we essentially have two screens that we run with. The first one on the left is referred to as our road flow, and I coin that as TUFLOW with training wheels. It's an extremely fast way to get a TUFLOW project up and running. Essentially all you need is a data train model, a rectangle, and filling in the panel. The second panel we have over here on the right is our more advanced. It has the full features of TUFLOW, a full TCF editor, and this one gives you all the options that you want to use. Now, we're going to use that with Quadtree, so for the moment I'm just going to tuck that away, and we're going to begin talking about SGS and SGS inside road flow. So the first thing we'll notice down here is that there's a new box, a new value inside our road flow panel, SGS distance. And essentially, that's all you have to do to fire up SGS inside 12D. Now that SGS distance has to be smaller than your cell size, and what it will do is in this case, every 0.5 of a meter, it will pick up an extra elevation along the sides and fill in a grid in the center of the cell. But we'll take a closer look at that in a moment or two. So, if we move that across just for a moment, their basic input data is that rectangle, the data train model, and our cell size. And in this case, we're going to be doing a constant rainfall on grid of 60 millimeters per hour. So we'll go hit the run button on that one. Now it's going to say, do you want to erase everything that was there before? And we're going to say yes, because road flow always erases and starts from scratch. Now, if you're used to running TUFLOW from a standard batch file, you're probably used to seeing a black screen pop up. Essentially what we do inside 12D is we capture those numbers and plot them for you. Now there's a bit of a pause when it starts up. What that is, this is road flow reading all those extra values, those SGS elevations, from what's called an XF4 file. We do want TUFLOW to start up as quickly as possible, so we do not write out our data train models inside a 12DA file, but rather we put the points out so that it gets running quickly. Now in this case, because we're running rainfall on grid, what you'll notice here is that we've got our outflow line here at the bottom. And because it's a constant rainfall in this case, we have, when the inflow equals the outflow, that outflow will stay constant. and I just might decide to end this job a little bit early, save a little bit of time in our presentation. The outflow is still rising, so we're not quite in an equilibrium yet, so we might just wait just a little bit longer. There's an indicator on the bottom here with an estimate of how long the TUFLOW run will take to complete, so another 2 minutes. And of course, we can see our modeling time down here on the bottom. Well, it looks like our outflow from the model is about constant now, so it's reached a steady state. So I'm just going to finish that a little bit early. It's going to confirm that I really do want to finish that, and I'm going to say yes. The panel will close, and there will be a brief analysis of the TUFLOW log file. And it'll tell us if there's any problems, but also in this case, for example, there was one, not a number, and it'll tell us that where that happened, and if we want more details, we can look at the log file to find out. Now, TUFLOW log file, if you're a TUFLOW user, you know it's practically your Bible for understanding what's going on. On our results tab, you have direct access to your log file where you could open it up and go edit it. Now let's take a look at what's been created before we go and read in the results. So I'm going to move across to our 3D check file. Now what happens when we go read results is it reads in a grid of the final grid that TUFLOW uses its analysis. So that's after your ridge and gully lines, after any kind of earthwork commands you use, it's the final one. So what we've done here is you can see we've taken a little bit of artistic liberty. The bottom of the cells are definitely flat. Now keep in mind this is the traditional non-SGS example. You can see how the sides have a horizontal side to them. And we take a little bit of liberty by rounding the corners to make them meet. But actually TUFLOW just has it straight horizontal on the 4 sides. Now that's what it would look like in a traditional run. As soon as we implement SGS, I'm going to bring up another view here to give us an idea of what that looks like. Now when Chris showed you one of those slides, he had a very good shot of a channel. And he discussed the importance of SGS when you have a straight channel that it aligns. But it's I think it's even more important, of course, when your channel keeps changing direction on you. And SGS gives such better results. So you can see here that the sides have, in this case, because of 0.5 meters, every 0.5 meters there's another point. So our sides have a shape to them. And the center of the cells also have those extra grid points, and those give you better storage calculations. So that's a very good visual for seeing what it looks like. The moment we go and read our results back in with RoadFlow, it automatically erases the old results and our check files, so that disappeared, and it brought in our new results. So to go take a look at those new results, I'm just going to back up for a moment, and you can see we've got our water level here, and it's being colored by the depth, and we've got some arrows pointing down here showing us the velocity vectors. If we want to these are the maximums from the job. If we go to our result controls, we can move from the maximums back to the beginning, time 0, and if we set that, it disappears. And of course now we can just step through that model, and you can see the results at any one of the time steps that we've selected. We're moving across in 1-minute intervals right now because that's what we asked for when we went and ran RoadFlow. So that gives you a basic introduction to SGS inside 12D model using RoadFlow, and essentially it was just putting in an extra value there. So let's say goodbye to RoadFlow for a moment, and I'm going to go bring the TCF editor back up. This was the same run, okay? Except now we're going to take a look exactly what RoadFlow created for us. You'll see that first of all that we have to be using the HPC solution scheme. The GPU is typically used for it but not required. These are the commands that make the SGS work. So first of all, it's turned on. There's a new approach method C, which is in beta right now, but I think you'll see it in the next release of TUFLOW. And it allows us to use the sample frequency rather than the distance. So we took that half meter, we took 3 divided by 0.5 and got 6, plus 1 for the ends. So the sample frequency is 7, so 7 points along the sides. So those are the extra 3 commands that put in. So you probably think in this point, not much work by 12D. However, our real work came in down here under the geometry. There's a new command down here for the XF SGS. And what this does is it sends, as I mentioned before, not just the elevations on the sides and the bottom, but the full SGS samples. And that's what makes TUFLOW start up so quickly when we're running, when it runs from 12D. So I think that does it for a moment, talking about how we get SGS working inside 12D. And now what I'd like to do is bring up another example of an urban area, and we'll use that urban area to discuss Quadtree. So I'm going to do my 2D urban area, and typically, once again, we would have an extent rectangle around the edge. But if we come in closer now, we've got another polygon we can specify where we want to have additional smaller cells, so a Quadtree refinement. And if we go take a look at what that Quadtree refinement would look like, if we come across here, you'll see that inside that polygon, you can probably see the cursor over there moving on the left, that cross. When I'm inside the polygon, I get a refined grid. So out here I have my standard 1 meter grid that I asked for, but then because I had a nested level of 2, it's gone down and made it half. Now I could have made a nested level of 3, which would have made it down into eighths, but always transitioning 2 at a time. So drawing the polygon was pretty easy. If you're ever drawing polygons inside 12D, make sure you know about this trace function. It is the best way to be drawing polygons. Now the other thing we needed on here was a way to specify that it was a level 2 Quadtree refinement, and that's assigned using our TUFLOW string editor. So if I was to go pick that, you'll see that that does have a nesting level of 2 assigned. If I had changed that to a 3, we would have had a 3 inside here, and it would have gone 1, 2, and then right into the 3. So that gives you an idea of what's involved in getting the Quadtree up and running. We are going to have to put extra commands into our TCF file. So let's bring up our TCF editor for this example and look at the extra required commands. So here's our TCF editor. Once again, if I go back to the editor tab, you'll see down here at the beginning that this looks very familiar. Smaller sub-grid sampling this time. But if we come down here, this is where the Quadtree happens. There's an extra command in there for a Quadtree control file. If we expand that, we'll see that there's 4 required commands. The first 3 say to get the basic data from the TUFLOW grid. Okay, so the TGC means the TUFLOW geometry control file, and that's where we'll get that data from. So the cell sizes, the orientation, extent, and the angle. But here's where we get to specify the nesting. So this polygon we've drawn is in a model called 2D Quadtree, and that's all we do is have to have that specified, and then off we go and we're running a Quadtree model. So I hope that was well, I should probably show you one more thing before we say goodbye to that one, is another view. This is sort of the plan view. This is what it looks like. If we went across into a 3D view, we can get a close idea of that image that Chris showed us when we're looking at the channels. We've got our basic base. Here's the 1 meter cell size. Here's our refinement, where we've gone down to a level 2 refinement. We have SGS turned on, so we have better defined edges for the flow. And if we go back and start looking at our channels, grab my orbit controller, okay, you can see that we well and truly get an excellent description of the shape of the sides and the storage in the bottom. So as a review then, the 2 things that we talked about were, first of all, the SGS and SGS inside the road flow, all you had to do is put in that extra number. And when it comes to working with Quadtree, you have to draw yourself an extra polygon for your refinement areas. And of course, you can have multiple ones. And put these commands into your TCF file. Now, as I've been going through here, I'm not sure if I mentioned it yet. You might have noticed that the toolbars up here are slightly different, and the menu is much, much smaller than the standard 12D. What we're doing is we're running the 12D water theme. So themes are a brand new part of version 15. Dylan did an excellent webinar on themes, and at the end of this presentation, we'll give you a slide that shows you the link to that presentation. So that concludes what we're going to present, and so now both Chris and I will be around to answer any questions that you may have.
Thanks, Rob. Actually, before we go to the questions, I might just quickly show the Quadtree SGS video produced by 12D of the Sheffield Water Quality Project. That'll give us an example of Sub-Grid Sampling and Quadtree used to analyze flow through a water quality structure. So I might just pop that video on for a moment. Bear with me.
Yeah, you can see here that as we go through, this is a fly-through done with timelines inside 12D, and then we've just merged back and forth between the visualization and some images that are taken from Google Earth. They've done a very good job of the visualization, everything from the plants to the weirs. But in there, you can also see, of course, the velocity vectors, the water ponding behind the weirs, and the water flowing across the paths. And I don't know if you noticed that, well, at the beginning, that grassed area inside the water quality ponds there was completely dry, and then, of course, filled up as the rain event continued.
Yes, thanks for that one. That was really interesting. So we'll just look at a couple of these questions that came through during the presentation. So this one came through during Chris, your section from Ali. It says, how does sampling distance affect the model runtime?
Yeah, good question. We've found that it actually has a pretty negligible effect. It'll slow down the initialization of the model slightly if you increase your sampling resolution dramatically. But to be completely honest, when you're dealing with, say, let's just say a sample resolution of less than 20 points within a single cell, you wouldn't really notice a difference. And once you get above a sampling distance or interval which is greater than 20, the impact on the results tends to diminish, so that you don't really see a tangible impact on your results, so you don't really go beyond that anyway. So yeah, it'll just slow down your model initialization a little bit, but it's not really noticeable, so nothing to worry about.
Thanks, Chris. And this one I think is for you, Rob. It's from Jacob. It says, can you show again how you'd add another Quadtree region for a channel, but maybe with a level of 3? Sorry, I hope I've read that out correctly, Jacob.
Okay, no, I think that makes sense. Let me just jump back into 12D for a moment then. So yeah, so the idea is that if you wanted to put another region in, it's really just a matter of drawing another polygon. So tools inside 12D, I'd use my eyedropper. Because I already have a polygon, I can go select an existing one, and it'll automatically populate my models and all that sort of thing across the toolbar. And then I mentioned earlier on that if you're going to be drawing polygons inside 12D, the way to do it is always with this trace option here, even if you're not planning on tracing. So what I'm going to do, this is actually where we have a creek along here. So if I was just going to put a polygon around that so I could get a Quadtree refinement, I would most likely just, if there's not snapping out in space, so I'd turn off my point and line snaps and make sure that I had my quick snap turned on. And then it's just a matter of clicking and drawing. So clicking along the edge here, if you haven't used your quick snaps before, might get that going for me. It's just a great way to quickly draw, because all you have to do is a middle mouse click each time you're looking for another vertex. So essentially working your way around. There we go. When you start getting near another refinement area, what's going to happen is it's the last polygon that's going to control the refinement. So if I was to purposely cross over into another area, what would happen is whatever the refinement of this later polygon would be the one that controls what the refinement would be in that intersected area. Generally, you don't want to interact. Usually, you'll try to be more specific about it. When you get to the end of your polygons, it's important that you do close them. With the trace function, you just hit the C for close. So essentially, I haven't drawn a very accurate one, but that's all it's needed to draw a new polygon. Often inside 12D, you'll just be tracing along road design strings, that sort of thing. Then, of course, we always have to assign those attributes, and we use a TUFLOW string editor. So there's our TUFLOW string editor up at the top there. I showed that earlier today. If I just go and pick that string, help I turn my snaps back on for us. And then we come in here and decide the nesting level. Now, we used a 2 for the roadways. If I wanted a lower one, I could put in a 3 inside there. And then, as Chris mentioned, it would go straight from the level 1 outside here, straight into the level 3. So it's got that automatic refinement if it's needed as well. So hopefully that answers your question. Essentially, that's all there is to putting in a refinement polygon.
Thanks, Rob. There's one here from Samuel. I'm not sure whether it's going to be too complicated to do live, but I'll read it out and maybe one of you will be able to help me. Can you explain or perhaps demonstrate the interaction of underground drainage and its improved capture in 12D with SGS enabled?
Yeah, there's two. Well, specifically, when you're working with 12D, when Chris was talking about the depths, inside 12D, especially at our sag pit locations, oops, let me zoom back into where we do have a sag pit. Give that a moment to catch up. There we go. Yeah, so what we're talking about here is that with more the classic method, we would always be using gully lines, and gully lines would bring down the cell sides, and because they were generally thin lines do not drop the cell centers. We'd be relying on the cell center being dropped for the to the grate level. So that's what would bring those two down together. I think when we're talking about the improved depth, because the storage in that area is so is much more accurately represented, having the extra subgrid sampling, that you, especially at the lower depths, you're going to get a finer resolution in the change in depth at those areas. So, Chris, did you want to jump in that one? I see that as being the big benefit for the subgrid sampling for the depths at SAGs. Did you have any other comments?
Not really. I agree with you wholeheartedly there. There's not much more I would add to that, to be honest.
Great. So I might leave the live question time there and just email through any other questions. So I think, Rob, you were talking about the themes in 12D model there. You did touch on that. Was there anything else that we wanted to just make sure everyone understood about the themes today?
Actually, yeah. Yes. What I might do is just drop back, if I can switch my screens back today. Yeah, the whole idea of themes. If you missed the webinar from Dylan on themes, take a note of that URL at the bottom, the 12d.com blog. Write that one down. It's definitely worth a note. It's one of the features in version 15 that, especially if you're new to 12D, or if you have a very specific interest, like only the water field, then having a simplified menu and a simplified set of toolbars really does make your work just a little bit easier. So yeah, take a look at that webinar. It's a very good one. Thanks, Lisa.
Thank you. And of course, we'll have these features and many more that we're going to delve into in far more detail at the 2021 Tech Forum, which is going to be an online event this October. So yeah, if you haven't gone online to learn more about that one, then that'll be a big event for us. The recording of today's webinar will be available in coming days through the webinars page on our website and on our 12D Model YouTube channel. Keep an eye on our emails and social media for details of future webinars. And if you're on the email list, then I always send out everything there, and everyone who registered today will get the link straight to this video so you can rewatch it all later. So we've got next week, I think Pavement Manager is the next one in the What's Coming webinar series. And we're going to have a few other topics coming up for that too. So what's new in 12D Synergy? There'll be I think Rob's going to entice him back for a dynamic drainage one later in the series as well. And yeah, if you need to contact us in the meantime, our details are on the screen now. That concludes today's presentation. Thank you all for attending. Thanks again to Rob and to Chris, and we hope to see you all again at future webinars.
Great. And thank you everyone for joining. Thank you, Lisa.
Thanks all. See you later.
Thanks.